Welcome everyone. My name is Junji Ma and I'm a solution engineer on the Esri Telecom team. Today I want to show our first official release, the next generation network management solution for telecommunications with utility network management, the communications data management for ArcGIS Enterprise. Working and starting from home has been a new normal for a lot of people and their families. In the world of telecom, carriers and internet service provider has been trying to keep up with the increased service demand on the existing bandwidth. In the meanwhile, telecom technologies are also evolving rapidly under any circumstances. Everything in telecom happens at somewhere. GIS provides an actual tools or technology that abstracting telecommunications and bring all the people, workflow, and data all together. All the different types of telecommunication networks are interconnected. This is the core value that we always keep in mind while innovating for the new geospatial solutions. And there is no reason for us to manage those mediums separately. There are many aspects within telecommunication infrastructure management. It goes all the way from marketing research, project management, network engineering, permitting, and construction, all the way to future operations and optimizations of the network. And that's why we need a platform that could bring this process together. And ArcGIS is the platform that I would love to share with you today, which support three fundamental systems. First, a system of record keeping, a transactional data management. Second, a system of insights, use analytics to analyze any data that we capture from the real world. And third, a system of engagement, which are the apps and maps that connect people and gather information to tell the stories. Let's talk about our communications data management for ArcGIS Enterprise, which is our next-gen enterprise solution for managing your telecommunication network. ArcGIS Utility Network Management is the foundational technology based on the next-generation enterprise GIS that is designed to meet the evolving need of utilities and telecommunications, as well as to serve communities, regional and international organizations in the telecom and utility space. It's a comprehensive and extensible approach that we took in creating advanced network modeling, visualization, embedded analytics, and also pervasive access throughout the organization. On the system of record side, we want our users to model the network from A to Z in both 2D and 3D environment. That's an obvious trend that we're seeing. People are wanting more and more details of their network. In terms of network tier, we study our users, community, and their use cases, and they guide us to create this data model that covers from submarine network to an indoor network facility. And we also put in feature that we could manage all types of network within one generic architecture. And speaking of analytics, Utility Network opens many doors for our users to interact and find patterns from the data. We could run various tracing or create and customize schematic diagrams from the selected features. After we have done a great job on the design, we would love to share that information across the organization. And that's when the system of engagement capabilities will come in natural in this scenario. The service-based architecture enables an integrated web GIS platform along with the secure REST APIs, providing mapping, analysis, data management, and collaboration with desktop, mobile, and web applications. As many of you have seen a demo for the early previews, I would love to show you what we are up to regarding the data model and showcasing the power of communications data management for ArcGIS Enterprise. The Communications Data Management for ArcGIS Enterprise is now available from the ArcGIS Solutions site. Users could easily find and deploy the solution directly to your ArcGIS online organization. Once the deployment is finished, you will find the item and solution package directly from the folder. Let's click on the solution itself and download the package to your local machine. Once you have easily downloaded the package, just unzip the file to your local machine. Now you can see all the items within this solution package are now ready at your fingertip. Let's open up the ArcGIS Pro project and take a look what's inside. Users will find 6 major components within the release solution package, and we highly recommend our users to explore every single one of them for more detail, especially for the task that will help us to go through the entire workflow. Let's open up the Communications Network Editor map, which provides an editing environment in ArcGIS Pro designed to streamline the creation and attribution of network assets. Let's take a look at the entire extent of the network within the sample data. The same as the early previews, we have provided some sample design for our users, and we've created some bookmarks for users to prioritize locations with special equipment modeling. Let's take a first look at this regional HUD location where we have non-spatial feature enabled, or the ports, racks, and shelves were previously modeled as spatial features are now modeled within the non-spatial object tables. And let's take a look at one of the distribution hub location where we have modeled the equipment with non-spatial objects. In a scenario where we have 2 types of network medium exchange, both fiber and coax are connected with a medium converter device to bridge the connectivity. Here is a visualization of the equipment modeling for the transition device for HFC network. And you could also see on both sides of the device there are coax cable and the fiber cable. And let's take a closer look at a network interface unit for a bigger building. There are multiple strands that are being attached to the ports within the equipment, and they're being modeled as non-spatial objects as well. Let's take a look at our last location, which is the microwave tower. By clicking on the tower structure itself, it shows the detailed inventory of baseband, radio unit, and antenna in non-spatial objects. Once again, we highly recommend our users to take a look at all the bookmarks for the equipment modeling details. Now it's time for some demonstration for design process. Let's take a look at this area of interest. We're trying to build a fiber route all the way from the regional HUD to this neighborhood. Let's go over to the editor template, and we can start digitizing some civil structure to support the new telecom network. I will start by placing some handholds along the route and creating trenches between each of them. And I will follow by placing a pole with riser and then creating some aerial span with poles along the route with the group templates. After we complete the second aerial segment, I can now go back and fix up the trench between the handhold and the pole. Next, I will proceed to create some vault location with knockouts and also some duct bank in between. First, I will place down a knockout location on the route, and then create an endpoint for where that duct bank will end. Now I'm going to place in 6 of those ducts within the duct bank. Now I'm going to add another pole with riser in between, and creating the last pole with this new pole with an aerial span, and also a trench from the pole location to this vault. And now I'm going to continue to complete the route by adding the last handhold at the end of the route, and using a trench to indicating where the trench will happen from the vault location to the handhold. Now I'm ready to place my distribution hub location, where I'm going to put it right next to the handhold. Now I've completed creating the structure routes. Now I'm ready to draw in my distribution fiber. Simply go into the editor template and select 72 strand count fiber with 6 buffer tubes, and starting from the regional HUD location and adding vertices along the route at every single structure point. and finally connecting to the distribution hub location. As you can see, the system is processing that editing task, and all this quick editing and automation are assisted by the attribute rules which are created by our solution team. Now the creation of the fiber cable along with the non-spatial strand has been complete. Let's go back and do a selection on one part of the route. We could clearly see all the containment association between the structure route and the fiber route. It passed through one of the duct within the duct bank and also the aerial spans and trenches. And all of this association was created during the cable creation process with the attribute rules. By repeating this step into the rest of the neighborhood, we can now create the rest of the network with the access cable and drop cable. Within this release of the non-spatial model, to create connectivity between ports within equipment requires users to take a couple more steps. For example, in this distribution hub location, we have a distribution hub that has 80 ports. 72 of them are from the distribution fiber, and also the rest of those are plugged into an access fiber. We'll first identify a port that was connecting to the upstream cable. We'll activate it in the Modify Association window. And then we go back and select the hub again and find a port that was connecting to the downstream access cable. By only selecting that specific port, I could now create that junction-to-junction connectivity from the Modify Association tool. This is a space that we're expecting users and partners to come into place and add value to creating some customized tools to help with the workflow. Using utility network management can ensure all the design integrity for the network completeness and avoid any human errors. To look at the details, right-click on the network utility network layer and expand on the rules. We have built in hundreds of junction-to-junction, junction-to-edge connectivity rules that model just like the actual network itself. Besides that, in order to increase our design efficiency, we have baked in some fundamental attribute rules within our datasets to help with the design process. Here's where we could see our users and partners come into place and start adding more and more of those attribute rules to help with the design process. Proper network management involves tracing your network to optimize paths for resources to travel. The utility network tracing function provides a framework that could be used to help deliver resources to customers, track the health of the network, and identify deteriorating areas. In this example, we're going to run an upstream trace from a customer premise. Simply select the network interface unit and expand it to find a port within the non-spatial object and set it as a starting point. By filling up all the parameters and start running the upstream trace, the return result will give us the entire path all the way back to the regional HUD location, along with all the structures and communication features along the route. Besides knowing all the features associated with the customer or business, what else can we do with the tracing result? And let's put them into a schematic diagram. Here's an example that we have run a trace from a hospital location. With all the return features, now we're ready to put it into a schematic diagram. So in order to do that, I'm going to use some out-of-the-box preset basic template. And what I have done is to go ahead and add some symbols and labels. And users could configure this layout and share it throughout the rest of the company as a template as well. There's one cool thing that I think I really want to show with you guys. It's when I select the portion within the schematic diagram, it brings me back to the actual location in the map. And vice versa, if I select a route on the map, and I could indicate it within my schematic diagrams. And this quick tip will help us more efficiently look into the network itself and identify more details regarding the strand network. Last but not least, communications data management for ArcGIS Enterprise leveraging utility network is 3D capable. So what's in front of us is actually a sample design for Redland office. And bringing in this web scene, we could see the building footprint and also the underground portion of the network and the aerial portion of the network. We can pan and zoom in this scene layer and going through the trees on the street level, looking at the cars coming at us. But also, if we want to look into an indoor network, it's now ready in this model. I'm zooming in one of the buildings that I sit in. And we see this capabilities opens the door for facility and building indoor network management, especially for the urban centers and central business districts. This solution, which leverages Esri's powerful ArcGIS utility network management, is going to serve as a foundation for supporting our users and partners in the telecommunication space. The communications data management for ArcGIS Enterprise is a future-proof enterprise solution that enables modern telecoms to design, manage, and operate the next-generation telecommunication network with unlimited possibilities. In the future, Esri's telecom solutions are evolving with telecom network technology. As users, you could always find the right and the best solution that fits your need. And please stay tuned on the upcoming demonstration videos for telecom related solutions and updates. Thank you guys very much for your time today, and I'll see you guys soon.